So the first one is number 1. It says find dy dx given 2y equals x squared plus sine y. Here's an example of an equation that would be really hard to solve for y, because y is the argument of this sine function, and there's this 2y over here. All right. So we'll take the derivative of 2y. So the derivative of 2y is just 2. But because it was a function that had a y in it, we would indicate that we would have done the derivative of it if we could. So we'll do 2 and then dy dx. Then equals x squared. So we'll do the derivative of x squared, which is 2x. I don't need anything next to that because this term is in terms of x. And then plus the derivative of sine of y is cosine of y. This one has a y in it. I would have done the derivative of y if I could, so I'm going to put a dy dx next to this one. Now this example is different from the one on the previous page because there's multiple locations where there's a dy dx. So our goal is to solve for dy dx. So to do this, step 1 is to get all the dy dx on one side. And I'll write some steps up here as we go through. Okay, so let's say I move the cosine over to the other side. So I'll have 2 dy dx. Then moving that over gives me minus cosine y dy dx equals 2x. Now, I have this dy dx in both. Since they have something in common, I can use that as a greatest common factor. So I'm going to factor out a dy dx. I'll put that over here. So if I take out a dy dx, then I'll have just 2 minus cosine y. The right side is still just 2x. So the next step would be to factor out a dy dx if necessary. Not all of the questions will make you do that, like the first one, but. And now you can just finish this off. So I want to move the 2, this is being multiplied together, so I'll just have to divide it so I can move it to the other side. So dy dx equals 2x over 2 minus cosine y. So our last step is going to be just divide, divide by whatever's next to the dy dx. Okay, let's look at another one. So number 6. Look, I only have one y in this one, so I'm not going to have multiple dy dx's. X equals tan y, so the derivative of x is just 1. I don't need to write anything else because this is already in terms of x. This one is not in terms of x. The derivative of tangent of y is secant squared of y. But then I would have done the derivative of y had I known what it was in terms of x. So I'm going to write dy dx next to that one to show that I would have done the chain rule. So all of my dy dx's are on one side already. I don't need to factor it out. I can just do the dividing step. So 1 over secant squared of y is dy dx. 1 over secant squared is just cosine squared, so I could write this one like that. All right, let's check out one more that's similar. So go ahead and try x equals sine y, number 10, on the next page. So if I do the derivative of that, the derivative of x is just 1. The derivative of sine is cosine. Since this is a y, we're going to have to put a dy dx next to it. So to solve, I'll do 1 over cosine of y is dy dx. 1 over cosine is just secant, so secant of y is dy dx. Okay, let's look at these last two that I boxed right here. They're similar to each other because they have like a product built in. So sometimes you're gonna have to use the product rule. So this one, the product rule is with the 18xy, and this one, the product rule is with the x and y in the middle. All right, but so we can use the 1d2 plus 2d1. So if you ever see a little product, like even this one, I'm gonna have to use the product rule when we do those. On 11, there's a product right there. 12, there's a product right there. So anytime you see something with an x and a y in it, we're gonna have to use the product rule. So the left side of this equation is normal. So the derivative of x cubed is 3x squared. The derivative of y cubed is 3y squared. But again, we don't know what y is, so we'll put dy dx next to that. Now on the other side, we have the product rule. So if you want to like kind of split this up in your brain, I'm going to split the 18x, and that's going to be like function 1, and just the y will be my function 2. That's supposed to be a 1. It looks pretty terrible. Function 1. So we're going to do 1d2 plus 2d1. So 1 is 18x. d2, so the derivative of y is just 1 dy dx. Plus 2, function 2 is y. And the derivative of function 1, 18x, the derivative of that is 18. Oops, function 1 should be 18x. There we go. I wrote that wrong. 1 d2 plus 2 d1. There we go. Now we have everything. So we want to get all of the dy dx's on one side. So maybe we'll move everything over to the left side. This guy that doesn't have a dy dx, we want to move that over to the right side. So let's do that all at once. So we'll do 3y squared dy dx. We'll move the 18x over as well. So minus 18x dy dx. And then on the right side, we'll have this y times 18, which is just 18y. And we'll be moving this 3x squared over to the other side, minus 3x squared. So we'll have to get one of these factored out. So we'll factor out a dy dx. And that'll leave us with, oops, factor out a 3y, or a dy dx. That'll leave us with 3y squared minus 18x equals 18y minus 3x squared. So to get our final answer, we'll have to divide by 3y squared minus 18x to get this by itself. I'll put this over here, dy dx equals 18y minus 3x squared all over 3y squared minus 18x. I'm going to leave that as my final answer. You might notice that all of these could be divided by 3, so you could do something like that to simplify, but that's how I'm going to leave it. Let's try one more with product rule, number 9. So I've got the product rule right here. So this is going to be my function 1, and this is going to be my function 2 when I get there. So I'm going to do, first I'll do the derivative of x cubed, so that's 3x squared. And then I'm going to do 1 d2, so 1 is x, d2 is the derivative of y, which is dy dx, plus 2, which is just y, and then the derivative of function 1, the derivative of x is just 1. So this whole thing is the product rule. Just like up here, this whole thing was the product rule. Now we have plus, now I'm going to do the derivative of y cubed, so 3y squared dy dx equals the derivative of 1, which is 0. So if I simplify this a little bit, I have these dy dx's that I'm going to keep together, and this 3x squared and this just y is really what this is. I'm going to move that to the other side. So I'm going to do this all at once. So we've got x dy dx, that's staying. 3y squared dy dx is also staying. On the right side, I'm going to move this over. So this is going to become negative 3x squared. And this is going to be moved over as well, minus y. Now I can factor out a dy dx. And I'll be left with x plus 3y squared. And then to get dy dx by itself, we'll move this to the other side by division. So dy dx equals negative 3x squared minus y all over x plus 3y squared. And that's our final answer. All right, we're going to do more of this next class. This is not the only time you're going to see this. So let me know if you have any questions. Have a good one.